Now we will prove the fact that each basis for a subspace V in Rn consists of the same number of vectors, which we called the dimension of the linear subspace V. Well, suppose that we have two bases for V. Yeah, one has p elements, so we take beta with p elements, v1, so vp, so this is a basis beta. And we have b prime with q elements, w1, w2 until wq. Then focus at b. The vectors v1, v2 until vp are linearly independent in V, which is a span of q other vectors. Yeah, since the vectors belong to a basis and are therefore linearly independent. And we already have shown that we need at least as many elements to span a subspace, and we can find linear independent ones. So that Q must be at least P. Yeah, this follows from the theorem that we need at least as many vectors to span V than we can find independent ones. So now maybe you have an intuition how to proceed, since there was nothing special in starting with B. If we would have started the reasoning with B prime, then we would have concluded that we have Q linearly independent vectors in V, because B prime is a basis, so its vectors are linearly independent. And we have that V is spanned by V1 to Vp. So that in the same way we conclude that P should be at least as large as Q. So now we have Q larger equal P and P larger equal Q. So we conclude that P must be equal to Q, which is actually what we needed to show in this theorem.